This is our third example of a design with one independent variable and independent groups. And here we've gone wild and have 6 independent groups. It's a study by Halagappa and colleagues on mice. And they're interested in the fascinating question of whether restricted eating, whether dieting may actually delay or decrease Alzheimer's. And they're working in mice, and they have 6 groups. 2 of the groups, labelled N, are normal mice, and 4 of the groups, labelled A, are Alzheimer-prone mice. And within the Alzheimer's, they have a group here, free, allowed to eat as much as they like, compared with diet, those restricted to 40% less food. And 10 refers to the age of the mice. So here we have 3 groups that are 10 months, middle age for mice, and 3 groups at 17 months, that's old age for mice. This page, like the previous one, allows 2 options. You can either enter just summary statistics or full data. And here we have the summary statistics for the performance of mice in this cognitive task, which is actually a swimming maze. Percent of time near target is what we measure, and the higher it is, the better the mice do. And here are the means and confidence intervals, of course, for the 6 independent groups. Now, we're going to extend the idea of subset contrasts to this example where we have 6 groups. And the first contrast I'm going to consider is oldies versus youngies. So I want the 17-month groups, which I might label my green subset, and the youngies, the middle age, the 10-month-olds, and there we go. Now you could do it the other way around, and that would be perfectly fine. You get a very similar diagram, but just blue and green swapped. And here I've got the mean of the 3 youngies, the mean of the 3 10 groups, so these are the middle-aged mice, and the green is the mean of the 3 old groups. And here we have the difference between green minus blue, so about 33 there minus about 37 there. Here are the numbers, 33.8 minus 36.8, difference of minus 3, and there's the confidence interval on that difference running from about minus 7 up to about little more than 1. And now if you know about percentage points of time near target, we can interpret this. It doesn't look like a very great difference, about 3 percentage points difference. And the confidence interval is moderately long compared with that, so we don't have any evidence that old and middle-aged mice are performing differently. Now, perhaps a more interesting subset contrast would be within the Alzheimer's. Let's compare the restricted eating versus the ad lib feeders. Now, it's usually easier when you turn off all these to start again. And so what we want is, let's say, we want performance for the diet group, the 2 groups together, so that's A3 and A6, so that's that and that. And we want to compare it with ad lib feeding, the free feeding, Alzheimer's 10, and the same for the oldies, and so that's 2 and 5, so that's 2 and 5, and there's the contrast we want. So this is performance by green, which is the restricted eating group, and here is the ad lib feeding. So it looks like those mice that were restricted to 40% less food performed distinctly better by about an average of 9 percentage points on this performance scale. This is very strong evidence that restricted eating does improve performance, and our estimate of to what extent it does is something between about 4 and 14 percentage points here. And we can draw a causal conclusion most likely because we've had random allocation to the diet and the ad lib feeding groups amongst these Alzheimer's mice. What lessons do I draw? Well, if we turn all these off and note that we have 6 means here, you could do exploration. You can just look at this and say, oh, that looks like quite a big difference. Now I wonder what that means, and think about that. Or let's combine these 2 and compare it with those 2. That would be exploration, But of course the risk is, because there are so many possibilities, so many comparisons, so many subset contrasts we could look at, there's a great risk we'd just be capitalising on chance. We'd be cherry-picking. We'd be seeing faces in the clouds. Now that's fine for exploration, but any conclusion, anything that looked interesting, could at most be just a hint, a suggestion, a speculation that might guide future research. Now that can be very valuable, but it's not a solid result that we could publish. What we would like to do is, based on previous research and our understanding of Alzheimer's and mice and diet and so on, set up a study like this, in advance of seeing the data, specify which subset contrasts are going to best correspond to our research questions, then specify those as planned contrast, planned comparisons, planned subset contrast in our pre-registered plan. Then, when we're all set, go and run the study exactly as planned, analyse it exactly as planned, and report those results, no matter what we found. We can then follow on, if we wished, and do some further exploration, but any conclusion would be just interesting speculation that might lead to further research. These one-way designs with more than two levels of the independent variable can be very effective because they allow us to ask quite a number of questions within the single study. How many comparisons or contrasts are we allowed to set up in our planned set of contrast or comparison? Well, one way to think about it is that here we have 6 means, so there are 5 degrees of freedom for the differences between these means. So if you like, we have 5 degrees of freedom to play with, and a maximum of 5 separate or independent or non-overlapping contrasts and comparisons we can specify. Now, doing 5 of them here, that's still quite a large number. Still a bit of a risk of capitalising on chance. But the important thing is that the contrasts or comparisons we specify in advance make conceptual sense. They fit best with our research questions. And it's best if we don't have too many. So 2 or 3 or 4 could be quite reasonable. Once we get much beyond that, then maybe we're risking capitalising on chance. When we get to exploration, we can do what we like, but then we only get tentative sorts of conclusions. I think this mouse is meant to be looking pretty clever and doesn't eat very much, whereas this mouse looks rather demented, and maybe because there's been rather too much food eaten. It would be a fabulous finding if restricting diet could lead to delay or reduction in Alzheimer's. The way is open for experiments now with humans.